Business Calculus, Topic 5, Homework. First, we'll take on problem number 25. Number 25, we have the integral of x to the 7th minus x to the 6th divided by 7x to the 8th minus 8x to the 7th power. I'm going to convert this into powers, so this will be x to the 7th minus x to the 6th. This becomes 7x to the 8th minus 8x to the 7th power to the negative 1 power dx. Now I'm going to use substitution. This part right here, we'll make that u. U will equal 7x to the 8th power minus 8x to the 7th. This implies that the derivative of u will be 56x to the 7th minus 56x to the 6th. Now all times dx. Now I'm going to factor out a 56 out of this, so we'll have du equals 56 x to the 7th minus x to the 6th dx. And now we have a substitution potential, only missing the 56 from here. So we're going to write the whole problem again. 7 minus x to the 6th, 7x to the 8th minus 8x to the 7th to the negative 1 dx. And this portion, right, we're going to add the 56 here and the reciprocal of 56 on the outside. So all of this right here will be du, whereas this right here will be u. Alright, so what we have is 1 over 56, the integral of u to the negative 1 power du. Now when I take the antiderivative of u to the negative 1 power, that's going to be natural log of absolute value of u plus c. Then we replace the u, we have 1 over 56 natural log of the absolute value of 7x to the 8th power minus 8x to the 7th power. Oops, this is the absolute value sign, and that's plus c. Now, let's try number, let's see, I think 27 was the next problem that was asked for. It's hard to separate today. Okay. All right. 27. 27 is the integral of x minus 3 all to the 1/4 power dx. Okay, well, for substitution, I'm going to take the x minus 3 for my substitution. U equals x minus 3. This implies that the derivative will be 1 dx, or just dx. So we have a replacement now for the dx, which will be du. We have a replacement for the x minus 3, which will be u. Problem is we don't have a replacement yet for the x. Well, u equals x minus 3 also implies that x equals u plus 3. So now we have a substitution for the x, u plus 3. So u plus 3, then u to the 1/4 power, and then du are all my substitutions. I will distribute my u to the 1/4 here, and we'll get u to the 5/4 power plus 3 u to the 1/4 power. Now the reason why I have 5/4 is because the exponent here is 1, understood 1, and when you multiply bases you add exponents. So 1/4 added to a 1 will be 5/4. Now for the antiderivative. The antiderivative of this will be I'll add 1 to the exponent. We'll have u to the 9/4, and then the reciprocal of 9/4 is 4/9. Next, we'll have add 1 to the 1/4. We'll have 5/4, and the reciprocal of 5/4 will be 4/5, and plus c. All right, from here, we're going to replace all the u's here. So we'll get 4/9. And the u here will be the x minus 3 to the 9/4 power plus, this will be 12/5, and x minus 3 to the 5/4 power plus c. I think the computer likes to keep the exponent as fractions, but if you were taking a test, you would write this as the fourth degree or fourth root of x minus 3 to the 9th power plus 12 over 5, and the fourth root of x minus 3 to the 5th power plus c. Okay. Another problem that was asked for will be 33. Okay. 33. We're asked to find the function, the area under the curve of 3 e to the negative x, and this is over the interval 0 to 10, and we'll have a number of rectangles will be 5. So we'll find this by using Riemann sums. Riemann sums is finding the area using rectangles. It's a bad looking rectangle. So we make rectangles under the curve. Okay. Alright, so this graph right here looks something like this. And we're going to create rectangles from 0 to 10. Now, the width of the rectangles are found by delta x, which is found by taking b minus a divided by n. The b in this case, this is b and this is a, will be 10 minus 0 all over 5. That equals 2. So that's the width of these rectangles, will be 2. Now, the height of the rectangles, we need to find the x's. The formula for finding the x's is xi equals a plus I times delta x. This finds the left side rectangles, or the x's, the left side x's. So we'll start with 0. So this will, and a is 0, I is 0, and delta x is 2. Then x1, we have a is still 0, I is now 1, and delta is 2. x2, a is still 0, plus 2 times 2. x3, 0 plus 3 times 2. And x4, 0 plus 4 times 2. This adds up to 0, this adds up to 2, this adds up to 4, this adds up to 6, and this adds up to 8. These are the x's that we need to put inside our function right here in order to get the height of each rectangle. So this will be f of 0, this will be f of 2, f of 4, f of 6, and f of 8. Okay. Now we're going to need to plug each one of those in and into the function f. So I'm going to get the function f. It's going to take me a second to actually put that in there. Here, I'll go ahead and go to, let's see, 3, my e, and that's raised to the negative x power. Okay. Alright, now I need to start putting some values for x. So 0 store x, and now I will bring my equation back, which is right here, 3e to the negative x, and we get 3. Now I'm going to store 2 into x, 2 store x, and then bring up my equation again, and now I have 0.406006. Okay, now let's make x 4. So 4 store x, second function entry brings up my equation again, press enter, and now I get 0.054947. Okay, now let's make x 6. So x 6 store into x, and bring up my equation once again, and we now have 0.0074 3, 6. And lastly, we're going to put in 8, store x, and bring up our equation, and we'll have 0.001006. Okay, now we're going to add all these together. There's a lot of decimals here, so I'm going to kind of cut things off right there just to make things faster. That'll be 3.4. If I can read my own writing, I think that's a 5. That'll be 17. So it goes up to about 6 and 18, should I say? So that's 3.4. Bring that up. Sorry. Okay, adding these numbers here, I get about 3.68. All right, and that's all the heights added up, and then you multiply it by 2, which is our delta. Okay, so you got the base times the height, or sorry, base times the height. And when I multiply this by 2, I'm going to end up with, let's see, 8 times 8 is 16, 6 times 6 is 12, plus 1 is 3, 8 plus 1 is 9, and 3 times 2 is 6. So this is about our approximate area right here.